Hello, welcome to this video, and in this video we'll be looking at the resultant of a vector. What exactly is it? A resultant is simply, as the word suggests, the outcome vector after combination of other vectors. It's the sum, really, of over other vectors. So say we have the vector A given by 2i plus 4j, the vector B given by negative 9i plus 5j, the vector C plus 6i minus 7j. The resultant vector of these vectors, if we're asked to get the resultant, would be simply the sum of these vectors. So the resultant, let's have it as letter R, of these would be A plus B plus C, which is, I have it in column form, 2i plus 4j, negative 9 plus 5j, and 6i minus 7j. Once I have that, I'll have my answer, negative 1i plus 2j. That's how I'd get the resultant of those. I had a scenario where I had a box, say, being pulled by a force of 2 newtons to the right and 7 newtons downwards. And I'm asked to calculate the resultant force on this, box. So we'd simply get this by representing these forces in vector form. You can see that this force is in fact 0 newtons, and the lower one is in fact 0, negative 7 newtons. And so the resultant force would be 2, negative 7 newtons. If you're asked to get the magnitude of this force, this will be, as we know it, the square root of 2 squared plus negative 7 all squared in newtons, and that's going to be root 53 newtons. You could also as well go ahead to get the direction that force is acting to the horizontal. You can see that this is, if you represented it like this, you have the 2 and the 7 downwards. So the angle you're looking at would be that angle right there. And that angle is going to be below the positive horizontal. And it's going to be equal to the arctan of 7 out of 2. So you could go ahead and do that if you've been asked to. Okay, so now a concept closely related with the resultant of vectors, or the resultant vector, is the unit vector. Now, unit vector is simply a vector of magnitude 1 that is parallel to a particular vector in question. So, say I have these two vectors. For example, I have the vector 1, 2, 1i, I plus 2j, and the vector 2i plus 4j in this case. If you look at that angle there, theta, and the angle alpha, you can prove that theta is equal to alpha. You could argue that these are similar triangles, or you could also use the fact that the tan of theta is equal to the tan of alpha by simply comparing them, since the tan of theta is 2 out of 1, which is also in fact equal to 4 out of 2. And so that tells us that these two vectors are in fact parallel, since the angle is the same. And what does that tell us? It tells us that parallel vectors can be written as scalar multiples of each other, because this 2, 4 is in fact 2 times 1, 2. You can also see that these direction ratios of these vectors, direction ratio is simply the ratio of the I component to the j component. They have the same direction ratio, which is 1 to 2. This is what tells us that they can actually be written as scalar multiples of each other. You could write 1, 2 as a half times 2, 4, or 2, 4 as twice times 1, 2. And this is unique to parallel vectors. And so The unit vector of a vector is a vector of magnitude 1 parallel to that particular vector. And so we want to find an expression for the unit vector. Let's say we have the vector r given by xi plus yj. We know that since the unit vector of r, which we're going to write like that, is parallel to r, then we could write it as a certain scalar times r. And we're calling that scalar k in this case. And we want to find k. What else do we know? We know that the magnitude of this vector is 1. And so the magnitude of k times xi plus yj, which is in fact kxi plus kyj, the magnitude of this is 1. But we know how to find the magnitude of vectors. It's the square root of the sums of the squares of the horizontal and vertical components. And we're equating this to 1. So this means that k times the square root of x squared plus y squared is 1, and therefore k is 1 out of the square root of x squared plus y squared. But realize that the square root of x squared plus y squared, if we come back to this equation, is in fact the magnitude of r. And therefore, the unit vector of a vector is simply 1 out of its magnitude times the vector itself. In other words, the factor that you multiply by the unit vector to get that vector is simply the magnitude of the vector that you have. Let's look at an example. Yeah, let's say we have the vector 15i minus 8j. The unit vector, we call this vector d. The unit vector of d would be 1 out of the magnitude of 15i minus 8j, which is in fact 15 squared plus negative 8 squared, all under the square root, times 15i minus 8j. And this gives you 15 out of 17i minus 8 out of 17j. This is the unit vector of this vector here. And you realize that if you go ahead and find the magnitude of this vector that you've got, the unit vector, you'll actually get 1. Okay. And so if you've been told that, say you have a vector of magnitude 34 units that's parallel to D, how would you find that vector? Remember, from this equation, we can get the equation that R is given by its magnitude multiplied by its unit vector. And so we know that for parallel vectors, they'll have the same unit vector, since the unit vector is only 1, and it's unique to a certain set of parallel vectors. Yeah. So if we have a vector whose magnitude is 34 units, that's parallel to D, that means that vector will have the same unit vector as D. And so its unit vector will also be this 15 out of 17i minus 8 out of 17j. And so that vector would be actually, if I called it uppercase B, would be actually 34 times 15 out of 17 minus 8 out of 17. This is I and j. And that would be 30i minus 16j. And that would be the vector. You realize that if you actually go ahead and find the magnitude of this, you'd get it as 34. And so that's how we work out those particular situations. So unit vector and the resultant vector concepts are usually combined in questions like these. And let's look at how we would solve it. So forces of magnitude 25 newtons and 40 newtons act along the directions given, determining the magnitude and direction of their resultant force. Okay, so we have a force of magnitude 25 newtons. Let's call it F1. The magnitude of F1 is 25 newtons. Yeah, we don't know what F1 is, but we've been told that it's acting along the direction 3, 4. In other words, it's parallel to F1 is parallel to the vector 3, 4. What does this mean? It means that they have the same unit vector. So that means that the unit vector of F1 is in fact the unit vector of 3, 4. How do we get the unit vector of 3, 4? It's going to be 1 out of the magnitude of 3, 4 times the vector 3, 4 itself. And this, when you work it out, is in fact 3 out of 5 I plus 4 out of 5, 4 out of 5j. And so the vector F1 is given by its magnitude 25 times its unit vector. And what does this give you? 25 by 5, it's 5 times 3, that's 15. 25 by 5, it's 5 times 4, that's 20. And so F1 is in fact 15I plus 20j in newtons. A similar thing can be done for F2. Magnitude is 40 newtons. We don't know what it is, but we know that it is parallel to 6, negative 8. And so the unit vector of F2 is in fact the unit vector of 6, negative 8. We go ahead to work that out. You realize that it is 3 out of 5, negative 4 out of 5, 6 out of 10, and negative 8 out of 10, which reduces to that. So F2 is in fact 40 times 3 out of 5 I plus negative 4 out of 5 j. And this gives us 24 negative 32, but in newtons. So we have F1 and F2, and we've been asked to get the resultant force. That means we have to add them. So we could use F to represent our resultant force. So the F1 plus F2, that's going to be 15, 20 plus 24 negative 32. Does this give us? This is going to be 39 minus 12. So the magnitude of this force is simply going to be the square root of 39 squared plus negative 12 squared. It's going to be newtons. And the direction, you see it's going to be 39 minus 12. So that angle is going to be below the horizontal. The angle is theta. Angle theta is equal to the arctan of 12 out of 39, which is the arctan of 4 out of 13. And so that's how you get your magnitude and direction of those forces. Okay, this is the end of this video.